The next type of power generating station that we are going to study is that which is making use of nuclear energy. So power plant based on nuclear energy. Here we are going to make use of nuclear energy that is obtained by the fission, that is breaking of nuclei of atoms like uranium or plutonium. So the energy that will be released due to the breaking of the nuclei of these atoms will be used to heat water so as to produce steam. This steam will be used to drive the turbines, which in turn will activate the generator so as to produce electrical energy. So we have fuel here. It is in the form of uranium or plutonium. We know that they are radioactive elements, and they are used in the nuclear reactor for nuclear fission. Nuclear fission means the breaking of the nucleus is brought about in the nuclear reactor. System for steam generation from water. So the heat that will be released during the breaking of the nucleus, that is fission, is used to heat water so as to produce steam. This steam is used to drive the steam turbines. The steam turbine in turn activates the generator and it produces electrical energy. Here also we have a system whereby the steam that is released loses pressure and temperature also is brought down. So this steam is then converted back into water so that it can be reused. So this is what is the nuclear power plant, and this is a flow chart which tells us the process that is followed in electrical generation using nuclear energy. Let us now try to understand the energy transformation in a nuclear power plant. Nuclear energy that is going to be obtained from uranium or plutonium is converted into thermal energy, because here the heat energy that will be released due to the fission reaction is used to heat the water. This water is converted into steam, and the steam has got kinetic energy, and this steam containing high pressure and it is at a very high temperature also is blown over the steam turbines. These steam turbines then start rotating, hence they also have kinetic energy, and eventually electrical energy is generated. So this is a flow chart which tells us about the energy transformation which takes place in a nuclear power plant. Let us now try to understand the process that takes place in the production of electrical energy using nuclear energy. We have already said that we make use of the fuel, that is uranium and plutonium, that are radioactive substances. The process that takes place is the nuclear fission, that is the breaking of the nucleus, or we can call it as the splitting up of a heavy nucleus into two lighter nuclei, along with the release of large amount of energy. So this process is called as nuclear fission, where a heavy nucleus gets split up into two lighter nuclei along with release of large amount of energy. Alpha, beta and gamma rays are also given out, and energy equal to 200 million electron volt is released per fission reaction. When neutron is bombarded on atom of uranium-235, it absorbs the neutron and converts it into its isotope uranium-236. So we have uranium-235. This is the atomic mass of uranium, and it is bombarded with a neutron. This neutron enters into the nucleus of uranium-235 and it gets converted into an isotope of uranium, that is uranium-236. Uranium-236, being extremely unstable, converts into atoms of barium and krypton through a process of fission, releasing 3 neutrons and 200 million electron volt energy. So if one neutron is bombarded on one uranium-235, it gets converted into uranium-236, but it being very unstable gets converted into barium and krypton, which are two lighter nuclei. And along with the formation of barium and krypton, it also gives rise to 3 more neutrons and energy equivalent to 200 million electron volts. So this energy that is released in the form of heat energy is then utilized to heat the water to convert into steam and to move the or rotate the turbines, which in turn activate generators and produce electrical energy. The 3 neutrons generated in this process cause fission of 3 other uranium-235 atoms, releasing more energy. Now 3 neutrons which are formed can enter 3 more uranium-235 nucleus and give rise to another barium krypton along with 9 neutrons and huge amount of heat energy. The neutrons released in this reaction release more energy through fission of more uranium nuclei. So in the first reaction, we found that 3 neutrons were formed. These 3 neutrons, on combining with uranium-235, gave rise to 9 neutrons. Now these 9 neutrons further can bring about the fission of more uranium nuclei, and every time you will be getting more and more amount of heat energy. This process of fission of uranium-235 atom continues and is called chain reaction. So number of neutrons will be formed and this process will constantly go on taking place of neutrons entering the nucleus of uranium and uranium getting split up into barium krypton, that is 2 lighter nuclei, along with more and more neutrons. So this is called as a chain reaction. In nuclear power plants, a controlled chain reaction results in release of thermal energy, which is used for electric energy generation. So in nuclear power plants, a controlled chain reaction is brought about. That is, extra neutrons are removed. For removing excess neutrons, we make use of cadmium rods. So using cadmium rods, we remove extra neutrons and only those many neutrons that are required to continue the reaction and give rise to a desired amount of heat energy are allowed to be there. Extra neutrons are removed with the help of cadmium rods. So the controlled chain reaction is brought about and it releases thermal energy which is used to produce electrical energy.